Ready? Okay. Cezary is here to talk about WebSockets for us. And it's going to be an interesting demo because he's going to be doing live testing at the same time. So he's with Nexmo as part of Vonage and has been doing this wonderful voice stuff for more than a decade now. Much more than a decade, if I saw correctly.
Yes.
So take it away.
Thank you. Hello, one, test? Yeah? Okay. Okay, welcome everyone. So, as you just heard, I work for Nexmo. I am responsible for part of the voice stack at Nexmo, mainly in regards to our API products. So I'm going to talk a little bit about something called WebSocket audio streaming. It's everyone knows WebSockets, but we kind of use it in a not really usual way because we transmit audio over WebSockets. And there are quite few interesting use cases with it. Okay, so the concept is very simple. We just send the raw audio data. In each packet, we basically send 20 milliseconds of audio, and that's it. Why WebSockets? Because protocol is very simple, it's well defined. It's been used for ages. It is implemented in all browsers. You don't have to reinvent the word or the wheel even. There are lots of WebSocket libraries. Any language pretty much is supported. It's very easy to load balance requests, to proxy, to do anything with that. And it's quite easy to integrate it also with JavaScript API with web audio, for example. Yeah. And the other reason why we use WebSocket is that most of the vendors of speech recognition, sentiment detection, all that stuff, the AWS, Microsoft, IBM Watson, they all use WebSocket to do the work. And also because the application to handle WebSocket, it could be very simple. Literally, I show you in my examples, you need probably less than 100 lines of code to do something interesting with WebSocket audio. Okay, so we some time ago we've developed a module for FreeSwitch that does it for us. It's called WS Bridge, although we had a few different names, but finally we renamed it to WS Bridge because it's a bridge between traditional telephony and WebSocket audio. Really started as a proof of concept with IBM Watson. One day someone came and said, oh, there's this new API from IBM and you can do cool things, and yeah, let's integrate it. And probably a week or two later we had a working proof of concept. Yeah, and I think we presented on this on one of the Watson conferences. It evolved to be general purpose audio WebSocket endpoint on FreeSwitch. it means you don't need to use it with IBM Watson or any specific vendor. You can actually receive the stream by yourself and do something with it. So the typical bridging scenario is that you send a zip call. You can in the zip call you can include the headers that the one of them is saying where to send the WebSocket audio, and the other one is specifying the format of the audio. And yeah, and as soon as a module receives that, it will start. It connects to WebSocket endpoint and starts streaming it. That's the dial plan example. That, as you can see, it's literally a couple lines, nothing special. And as you can see, it's an endpoint. It's slightly different from usual approach that it's already in free switch, which I mean they treat this kind of calls as a ASR, special ASR endpoint that glues to the audio, to existing audio. For us, it's just an endpoint. Okay, so what's internally? So as I said, it's an endpoint module for free switch. It's built on top of WebSockets. It supports both WS and secure WebSockets. At the moment, it supports two audio formats. It's 8 kHz and 16 kHz audio. And so that means each message carries 20 milliseconds of audio, which is usually 640 bytes or 320 if it's 8 kilohertz. It's a two-way connection, so as soon as the connection is established, you can also receive data and send data to the endpoint at the same time. And at the moment, it works as a client, so the module is always initiating the connection. A little bit about performance. We tested it long time ago. We haven't done any tests like that recently, but when we tested it, we had pretty good results. On the 8-core virtual machine, we achieved around 300 concurrent calls with just echo application on the other side. So it was actually two-way audio. Okay. So I have a couple demos now. First, by the way, all the demos I'll be showing, they are open source, and you can try. You can just check out the code and try it. Probably for some of the demos, you need to have credentials to Microsoft Azure or Google to really experience the what it can do. So on the first demo, a very simple scenario. So we make a call. So first of all, we make a SIP call from anywhere. We call a simple Python script that receives the WebSocket audio, and on the other side, the simple server provides a simple website, web page that allows you to stream audio files that are on that server. Let me. So that's the page. I'll try to. You can try to call the number, but you probably only one person will be can hear that. So I'm using Zyper actually. Let's test if the audio works.
Please wait while we connect you.
Okay. So we connected already. So there is a simple Python script receiving. As you can see, we are also receiving some events that come from our platform. And all it can do is if I click the one of the buttons, I order the script to send the raw audio from to the WebSocket endpoint.
This is a tasty burger.
So yeah, very simple. Very simple demo. I'll switch to another demo now. So I explain how it works. It's slightly different. The first part is the same. We make an inbound call. We convert it to WebSocket audio. At the same time, we can connect one web client or more web clients, basically the simple server will send audio to web applications, and web application will play it through web audio API. So if anyone wants, we can actually call the number. If not, I will call it. Oh, James is calling.
One, two. 1, 2, 3.
There's probably a slightly delay, but as you can see, there's no WebRTC involved. We're just streaming audio. So we have a number of inbound calls, and we're just streaming those audio calls to web browser. Simple as that. Okay. Another demo, even more sophisticated. So same as before, we have an inbound call going to very similar Python server. Python will we basically send the same package to Azure Speech API because it needs to do some authentication with tokens and etc. And at the same time, the Azure Speech to text will send us back results of the speech recognition, and we'll display it on a web client. So James, again, do you wanna? Let me just. Sorry. Do you want to say something?
I am saying something. I am saying something.
You can see. You say.
Hello, Cezary.
It's not my fault, it's the Microsoft speech. Yeah.
I love dangerous demos.
Yeah, that actually works. Okay. Okay, that's what demos I had. Yes. So as you can see, yeah, it's very simple. I can show you I'll show the scripts later. They're very simple scripts. Integrations. We have integrations with Lex, with the AWX. So you can actually build your bots. And there are people in the community doing it. As I said, everything is open source. Go and have a look and try out. IBM Watson. If I understand correctly, you don't actually need any extra scripts to talk to IBM Watson. You can just, if you're using our API, you can just send your token, whatever it is, and it will, and point it to IBM Watson URL, and it will just work. You don't need anything extra in the middle. So it can do speech transcription and sentiment analysis. Again, examples are there. Google Cloud Speech as well works. I had actually an example of Google Cloud Speech, but for some reason it stopped working. And it's not being hosted by me, so I have no. I couldn't make it working. Probably some keys or credential expired, but the story. Okay, and there's actually a example of building a phone on a Raspberry Pi with two-way audio, speaking to our WebSocket audio API. Yeah, if anyone want to play, also works. Okay, what's left to do? We would like to, customers actually asking for support for Orbis/Opus. So I think it's on our radar somewhere. So we want to implement it as well. But we are open to any contribution. If anyone wants to join us with that. Multi-channel stream, very interesting scenario where you, for example, when you have a conference call and we want to try and transcribe all the participants from the call, you want to send them, all the participants in a separate channel, because otherwise the speech-to-text engine would just say no. They need to be in a separate channels. So that's probably will be earlier than org/opus. What else? There's a possibility of making inbound WebSocket calls that would be easier to probably integrate with customer scripts/infrastructure. So customer will be making calls to us, not always us calling an endpoint on the other side. And I've heard the customers are asking for it as well. There is some work to be done on the lower layer. The Leap WebSocket is a single threaded, so it's not as performant as we would expect, but as you saw with our results, it works quite nice. Everything is on GitHub. As I said, it's a free switch module, so you need to compile it together in free switch and load as a module, and it should just work. It should just work with latest free switch. These are the people that mostly work on it. Some of them stay with us, some unfortunately not. Yeah, and we are hiring as well. We have some positions open, so feel free to check out. And
Thank you.
okay, thank you. Any
Thank
questions?
you all. Before I let you get to the questions, and I'm going to start with in the back with Tori, I'm going to do the administrative stuff before everybody runs out to lunch, which is where we go next. Lunch starts at 12:30. Reminder, everybody, don't drink much before the evening activities today, or you won't be allowed on the segways or into the Zumba balls. Apparently, they don't want people to run over hamster balls or get drunk on the segways. And at 7 p.m., we'll be watching England trounce Belgium. And based on that, I'm going to give our #1 Belgian fan the first shot at it.
With regards to WebSocket calling, I've experimented many years ago in the past with trying to do calls over TCP, and it works all nice and great until the instant that there's a network hiccup, and then you suddenly have a fixed delay of 4 or 5 seconds. Mm-hmm. Do you have any mechanism to detect that the WebSocket buffer is full and to discard or to catch up or anything like that?
Yes, we have a ring buffer, and if it's, there is some mechanism to prevent those issues. Yes, of course it's best because it meant to be for real-time stuff and for real-time audio transcription. So it's better to make sure the connections are good. And in case you're speaking to those big names such as Google, Microsoft, it's usually good. Almost always.
Second, we'll give it to Steve.
Well, we have a product which is WebRTC with Drachtio for a proxy and free switch for back-to-backing. And in the lab, we've got real-time transcription using the Google transcription stuff. At the moment, though, we have to stream the audio to Google from the agent client because we can't find a way to stream real-time recording out of FreeSwitch from a bridge. So is there a way to do that? Since I couldn't find any way, and of course the FreeSwitch project won't support you. Yeah.
So as I said, you can send you can actually use it to send real-time audio from FreeSwitch.
But it's got to bridge to your module, whereas I've got a bridge between two endpoints, and I want a third stream out of there going to Google.
Yeah. So the way we use it, so in our platform. In our API product, every call, it's actually a conference call. So for us, it's easy. We just attach this person to conference. Yes.
So you add another participant to the conference, and that's pushing it up.
Which is special participant. Yes.
They can't hear you on the recording.
Oh, it's not worth hearing me on the recording, is it? Thank you.
Yes. Anybody else?
If you want, I can give an answer to that.
Okay, we've got an answer.
So, have you tried mod eavesdrop?
No.
Okay, so if you, on your A channel, if you set mod eavesdrop, it's a free switch application that you can run in the dial plan, and it will basically eavesdrop on any channel, depends on the codec, and then you can give it a new destination, which could be a SIP endpoint or a WebRTC endpoint, or maybe even a voice over WebSocket endpoint. But I know that it at least does SIP, so you could always send that SIP through some sort of proxy that converts it into...
So we usually RTC on both sides, but yeah, I'll
Okay. Yeah, mod eavesdrop is awesome.
Anyone else? Marie? Okay, you guys have 10 minutes until lunch. We're back in 1877 for lunch. Remember, try not to be hammered before you ride the segways.